Hi, my name is Jacob Francis, and I will be giving a presentation on social analytics using the Wolfram language. Basically, I was invited a few weeks ago to just give a kind of like a rundown, give some insight into what I learned, and then also just to kind of talk about my project. Here with a couple other camp students as well, you might have seen us walking around, but I don't expect this to go for the entire 20-minute period, so if you guys have any questions, feel free to ask me. But yeah, so essentially my project was a social analytics project. It's looking at, well, specifically Twitter for the social media network. It's looking at trying to connect emojis and actual tweets and kind of created an association between them to find the way that Twitter users most commonly use emojis. So you'll be able to kind of see visualizations of this later, but essentially the best way to describe this is that emojis are a nice way of depicting actual human emotion, whereas sometimes it's hard to decipher what someone actually means in their text. So it's kind of taking a look at that, sifting through a large query of tweets to kind of make sense of, how do Twitter users actually use this stuff. So essentially, using the Service Connect function or feature, I should say, in the Wolfram language made everything very easy. So this is just kind of, it didn't actually do anything on Elon Musk, but this is just kind of looking at a way that you can very easily pull a number of tweets. So if I wanted to pull 10 tweets from Elon Musk, just being able to do that gives me everything from the username, URL for the specific tweet, all kinds of stuff like that. And then actually going into the sentiment of the tweet, I actually just used Wolfram's built-in classifier. So I didn't develop any kind of neural network or anything for myself. I just used the built-in one, and kind of showing how you can go through the different text in those tweets and be able to determine what the sentiment of those tweets were. So basically, there was a lot of, now I already pulled a query. This is a query that I pulled a long time ago because there was over 24,000 tweets that had to be sifted through. Basically, I set up all my functions initially in the beginning, so I might refer back to these, so I might be popping back and forth. But there was basically these 7 main functions that I had to refer to for actually creating those associations and then also creating the data visualizations. So for, actually I will just refer back to these because without context they don't make a whole lot of sense. But just know that they're for pulling information from using Service Connect. They're there for creating the data visualizations and then also for sorting data so that it looks a little bit nicer, basically. So first thing I had to do, because Wolfram doesn't by default, unless you're using the Apple Color emoji font, doesn't by default actually represent the emojis correctly. I just rasterized them because I didn't want to change the entire font of my entire notebook. So by doing that, then you get just a list of basically small images so that they're easy to use throughout the rest of the project. And this took actually a longer time than you might expect, just because it took me honestly a week and a half to actually figure out how to use or visually see the emojis within here. It was help with Rick, who was my mentor at the camp, to actually be able to figure out how to use emojis. There was a lot of hiccups with them. Now, this is like an example right here, this get sentiment of my tweets, which tweets, again, is that pre-pulled query. It's just a very big list, essentially, of tweets that I'm hiding just because it's really ugly. But I'm using the get sentiment function. Basically, what it's doing is just a list of lists of different tweets, and then they all map with different emojis. So what this is doing is it's iterating through and just applying that classifier function to each of those tweets to determine whether they are positive, negative, or neutral, and then also getting rid of any that are indeterminate to work out, kind of get rid of any outliers. So then by doing this, it takes actually surprisingly quick how fast it's able to do it, considering, like I said, there's about 24,000 tweets that it has to go through. But that was what I did essentially, just to kind of first take all of the tweets and then condense them down into a format that was understandable, and then taking that and then just getting a positive, negative, neutral for all of those. After that, though, this is just an example of, this is actually the wrong spot. This is kind of an example of, if I can make this a little bit bigger, or this one a little bigger. kind of looking at the actual individual distribution of sentiments for a given emoji. So I think that it's important to kind of see, is it used in a mostly negative and mostly positive 50-50? Is it used 50-50 positive and negative most of the time? Is it used in a mostly positive way a lot of the time? So you can kind of look at some of the ways that users are using these different emoticons on Twitter in more depth. But then following that, right here, basically to actually take a look at like numerical values for this, because you can look at positive, negative, and neutral all day and it won't really make any sense. What I did is, I just formulated this myself. It's not really anything that complicated. Basically, I just gave everything a score. So if it's positive, it was 1. If it was negative, it was -1. And if it was neutral, it was 0. So I just created basically keys and values to do that. And right here, essentially all I'm doing is iterating through all of that raw data, creating those maps between the actual physical words and then the numerical values, and then finding a total score, so to speak. So, because if an emoji is mostly used in a positive context, it's going to have more weights in the positive one direction, more in the negative one. And so being able to do that, and this is just a list, essentially, which again still correlates with another list of their corresponding emojis, but creates a list that actually gives you a numerical representation of its sentiment or its net sentiment score. And so then this was just kind of curious. This was something that sparked my interest. When I went through and actually found the most negative emoji, the most negative emoji is actually the thinking emoji. So it's really weird. I don't know why it's doing a little. It's kind of small. I know the rasterizations are quite small, but it's doing a little like thinking. It's a thinking emoji. And now my just because I use Twitter, so my hypothesis would be that most people use it in a sarcastic sense a lot of the time. So when you think of like the way that the classifier function is looking at it, it's looking at it just in terms of what it's literally saying, and then you get that aspect of actual human emotion with the emoji, so you can kind of determine, well, maybe because this isn't the thinking emoji, as shown here, doesn't seem to have, just by looking at it, necessarily a negative or positive sentiment to it. So kind of looking at the weird quirks about how people use different emojis on Twitter. Just thought that was kind of interesting. Now, in addition to this, I actually got like a distribution of all the different emojis. Now this is very hard to see just because had like 200, or not 200, 100 something emojis. Not all of them. There are way more than that, but that would have been a lot of tweets to pull. But basically, I had to first sort through. This is referring back to another function that I had before. I'll actually go back to it real quick. The sort emojis function right here. All this is really doing is just sorting the emojis based on the ordering of that list that I had from before, based on their net sentiment scores. So first it's taking that list of just numerical values for each emoji, it's sorting those, and then it's also sorting that list of emojis based on the same ordering of the other list that I had. That way you can get you can sort both the emojis list and the list of actual scores so that they are aligned with each other. So basically, by running this, it's going to give me the same output, but that just then allows me to go and create a bar chart that isn't just it's not just going up and down all over the place. You get kind of a continual progression from most negative to most positive. And like I said, these are very hard and small and hard to see. But the most positive one is actually, it's an emoji with stars in its eyes. And actually, not really ironic, but that's actually the one that was right here, which is right next to the most negative one. But that one was, I guess, by no surprise positive, but the second most positive one is actually an angry emoji, which is this guy right here. So again, looking at potentially how these are used in a sarcastic sense, or a sense that I guess doesn't make to most people who don't use these forms of social media. Now, if you want to look at kind of more of a cellular or a table, I also just set up a function for creating a data set, because if you want to take a look at, well, a pie chart's great for visualization, and a bar chart's great for like looking at all the data in a very coherent way, or a way that just represents all the data in one easy to see fashion. But a data set, I think, just in terms of looking at numerical values is great because you are able to just take a look at just the numbers again, but more easily represented than something like a list. And that just kind of gives you, well, this is how people are using them, and also kind of showing you the balance between the two. Like for example here, this emoji is pretty balanced, as you can see, between positive and negative. And then you have other ones that are skewed. Just another way to look at the data as well. But that was really the essence of my project this summer. I planned on expanding this a little bit. I was actually going to be looking at not so much emojis, but actually the progression, I should say, of sentiment in a specific user. So kind of as I did on the first slide when I was looking at Elon Musk's tweets, being able to, there's actually a date associated with that. So then using just a date list plot or a date plot, not sure which one I would want to use exactly, but that being able to pull, because you can pull up to 5,000, or I believe it's up to 5,000 tweets in one single query, being able to do that and then group by date and then graph actual net sentiment over time to see, well, I was just curious because especially with all the fire that Elon Musk has been recently with the SEC and all that stuff, being able to see, well, maybe he's becoming more irritable on Twitter. But that was something, unfortunately, I wasn't able to do before this conference. But yeah, that was pretty much the essence of my summer project. I went into a lot more detail than we had about 2 minutes to give a presentation at the actual camp. But yeah, I suppose that's really about all for my entire project, though. Is there any questions or anything like that? Thank you.